So let's look at the process of simplifying a radical. And before we begin, just to remind you, if I have something like x cubed, and I take the cube root of that, I'm going to wind up with x. Or if I had p to the fourth, and I took the fourth root of that, I would have just p. Or if I had, y to the seventh, and I took the seventh root of that, I would have just y. So simplifying a radical means getting everything out of the radical sign that I possibly can. So, just as a different example here, if I just had the square root of x, there's nothing I can do with that. I mean, the square root of x is the square root of x. But if it was, say, the square root of x squared, well, then the square root kind of gets rid of the squared. It's an inverse operation, and I would be left with just x. So these are some things. This is kind of the foundation of what I want you to know for simplifying a radical. So here we have slightly more complex radical, and I'm going to use the product property of radicals to kind of divide this into three pieces. After you do this enough times, you can kind of do it without dividing it up like this, but it's not a bad idea just to divide it up. So I have the cube root of 40 times the cube root of a to the eighth times the cube root of b to the fourth. Well, let's leave the 40 off to the side for just a second, and let's start with the cube root of a to the eighth. So the cube root of a to the eighth, I could rewrite that as the cube root of a cubed times a cubed times a squared. Because remember, if I multiply these together, I add the exponents, and I have 3 plus 3 is 6 plus 2 is 8. So if I divided this up into pieces, I would have, well, let me do it a little bit better here. I would have the cube root of a cubed times the cube root of a cubed times the cube root of a squared. Well, we know from what we did before that this is simply a, and this is simply a. So I have a times a times the cube root of a squared, which I can't do anything about that. So right here I have a times a, that is a squared times the cube root of a squared. And that's how I simplify this piece right here. Let's look at this piece over here. Well, I am going to divide that up into the cube root of b cubed times b, which is like b to the first, because remember, if I'm multiplying with the same base, I add the exponents, so 3 plus 1 is 4. And if I use the product property, I could divide this. I go the cube root of b cubed times the cube root of b, and that gives me b times the cube root of b. So one of the ways I look at it is I'm trying to get as many b cubes out of here as I possibly can. Over here, I was trying to get as many a cubes as I can out of this, because then I'm taking the cube root of an a cubed, and I then can pull an a outside the radical sign. So I've done this piece here, and I've done this piece here. Let's go take a look at this cube root of 40. Just like when I started this problem, I want to find as many perfect cubes underneath the radical sign as I can so that I can move them out. So in order to do that, I really need to know what are my perfect cubes. So for the number 1, the perfect cube is 1. For the number 2, the perfect cube is 8. So 2 cubed is 8. 1 cubed is 1. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. And really, these are as many as I've memorized. I haven't memorized any others, right? But and you should know these. You should really have these memorized. So if I'm thinking about this 40 over here, I'm thinking, well, just like with this a to the 8th, I was able to separate that into a cubed times a cubed times a squared. Is there any perfect cube that is a factor of 40? And I come over and I look at my list and I'm saying, well, yeah, 8 is a perfect cube that's a factor of 40. So I could change this to the cube root of 8 times 5. And we know that the cube root, that 8, we know that 8 is the same thing as 2 cubed times 5. So I could do the same thing and I could divide this up using the product property. I have the cube root of 2 cubed times the cube root of 5, and that gives me 2 times the cube root of 5. So again, I'm looking for perfect cubes because my root here is a cube root of 40, and this is what I got. So if I'm looking to take this whole thing now and simplify it, I'm going to have 2 times the cube root of 5 times a squared cube root a squared times b cube root b. And since this is all being multiplied here, that's a multiplication sign right there. And that's a multiplication sign right there. I can rearrange those to make it look a little bit nicer. And I'm going to put everything with a cube root radical sign together. So I'm going to have my 2a squared b, that's the 2a squared b, which are not under the radical sign, times the cube root of 5 times the cube root of a squared times the cube root of b. And again, with the product property, up here we were dividing things out underneath the radicand. Now we're going to combine them. So this whole thing is going to be the cube root of 5a squared b, and outside the radical sign is 2a squared b. So this is my answer. This is the simplification of that. I've gotten everything out of the radical sign that I possibly can. I've gotten this 2a squared b out of the radical sign, and that just leaves the 5a squared b underneath the radical sign.